At the end of this video, you should be able to perform mathematical operations involving significant figures. Chapter 2, Section 3, Addition or Subtraction with Significant Figures. Consider two mass measurements, 25.1 grams and 2.03 grams. The first measurement, 25.1 grams, has one digit to the right of the decimal point, in the tenths place. There is no information on possible values for the hundredths place. That place is simply blank and cannot be assumed to be 0. The other measurement, 2.03 grams, has two digits to the right of the decimal point. It provides information up to and including the hundredths place. Suppose you were asked to add the two measurements. Simply carrying out the addition would result in an answer of 27.13 grams. That answer suggests there is certainty all the way to the hundredths place. However, that result is not justified because the hundredths place in 25.1 grams is completely unknown. The answer must be adjusted to reflect the uncertainty in the numbers being added. When adding or subtracting decimals, the answer must have the same number of digits to the right of the decimal point as there are in the measurement having the fewest digits to the right of the decimal point. When working with whole numbers, the answer should be rounded so that the final digit is in the same place as the leftmost uncertain digit. Comparing the two values, 25.1 grams and 2.03 grams, the measurement with the fewest digits to the right of the decimal is 25.1 grams. It has only one such digit. Following the rule, the answer must be rounded so that it has no more than one digit to the right of the decimal point. It should be rounded to 27.1 grams. Multiplication and division with significant figures. Suppose you calculated the density of an object that has a mass of 3.05 grams and a volume of 8.47 milliliters. The following division on a calculator will give a value of 0.3600944451. The answer must be rounded to the correct number of significant figures. The values of mass and volume used to obtain the answer have only 3 significant figures each. The degree of uncertainty in each calculated result is not justified. For multiplication or division, the answer can have no more significant figures than that are in the measurement with the fewest number of significant figures. In the calculation just described, the answer, 0.3600944451 grams per milliliter, would be rounded to 3 significant figures to match the significant figures in 8.47 milliliters and 3.05 grams. The answer would thus be 0.360 grams per milliliter. Conversion factors and significant figures. Earlier in this chapter, you learned how conversion factors are used to change one unit to another. Such conversion factors are typically exact. That is, there is no uncertainty in them. For example, there are exactly 100 centimeters in a meter. If you were to use the conversion factor 100 centimeters over 1 meter to change meters to centimeters, the 100 would not limit the degree of certainty in the answer. Thus, 4.608 meters could be converted to centimeters as shown on page 50 of your text or on the screen now. The answer still has 4 significant figures. Because the conversion factor is considered exact, the answer would not be rounded. Most exact conversion factors are defined rather than measured quantities. Counted numbers also produce conversion factors of unlimited precision. For example, if you counted that there are 10 test tubes for every student, that would produce an exact conversion factor of 10 test tubes per student. There is no uncertainty in that factor. At this point, you should be able to perform mathematical operations involving significant figures.